My name is Paul. I'm a DevOps at Coolblue. Well, I saw a lot of hands when we talked about ordering at Coolblue, but for the one that doesn't have any experience with Coolblue, a short introduction about who we are. We are one of the largest e-commerce companies in the Benelux. I have around 1,100 colleagues at the moment, and we have 334 web shops, both in Netherlands and in Belgium. We have 5 physical stores in the Netherlands and 2 in Belgium. And we have 2 warehouses and working on a 3rd one in Tilburg to supply in our growth. Like I already mentioned, all our mission critical software is developed in-house, and yeah, we're growing every 20 months, or are we doubling in size, not only in colleagues but also in our revenue and our traffic. Everything sums up about doubling each 20 months. But that's not why we are here. Today we're talking about how we deploy our software. And to us, deploying software is delivering packages of high quality software on servers. And yeah, we do that around 50 times a day for the web platform, the e-commerce platform. I wasn't able to get better statistics of the back office. And we provided a system so that developers can do their own deployment with a single button click. And eventually we want to remove that single button click. But I'll come back to that later on. We develop applications in .NET, in PHP, Node.js, but what I'm going to tell you here, the tools might differ, but all the other stuff, the principles are the same, no matter what language or for which environment we build stuff. So yeah, let's start our deployment journey. I've made a kick-ass conversion killer for the web shop. I really know that will help conversion, and we need to get it out on production. So what is involved in that? Well, I know that I have my code written and I have it unit tested, so I know that my code is working, functionality is working, and preferably I've run all the other tests, so I know I didn't break any other functionality. So that's a check, did that. I've applied the coding standards, so I know my indentation is right and I didn't have any unused variables because we don't want all that stuff. So that's something I've applied in my code, and I'm absolutely sure that it's there. There are no errors or something. So the next step is to get it on our code management repository tool, which is GitHub. Now, I saw a lot of hands when we described GitHub, so let's not dive into that. And all our developers have their own fork. So we have a repository which has the main line that is Coolblue owned, and all the developers have their own forks in which they work on. So my kick-ass killer function, I committed to my own fork. Now I need to get it into the main line. In order to do that, I open up a pull request which basically say my changes of what's in my repository needs to be merged into that main repository line. And the nice thing about pull requests is that it's something visible. That's what we love about GitHub, that I can easily share a pull request and send it to my teammates or to another developer in the company and ask for a review, just a peer review. Hey, do you think what I'm doing, if that's great, or should I take another approach? And another thing about pull requests, we like them small. We want very small commits that we can easily go into production, and not very big ones, because, well, first of all, they are hard to review. If the context is big, then it's not easy for me as a reviewer to understand what is happening, what is the change that you are doing. So I want to keep it small for my reviewer, but also when I put my change in production, I really want to know which bits and pieces of the pull request is causing for an outage or for some other kind of error, which makes it easier if I have a small pull request and put that into production than a very large one. So like I already said, easy thing of pull requests is that we can share it. What we do in Coolblue, when I commit some functionality or change, I send that to my teammates to have a check on it. They will check if well, my solution is okay, if I still didn't break coding standards, if I have unit tests for it, and if it's, well, is it logical what I'm doing there in that change. So yeah, my teammate said, yeah, you're awesome, you did a good job. Let's see if we can get it into pull request, or that we can get it merged into the main line, which is pretty okay, but we humans, we tend to not be so great in repetitive tasks. Well, hard word. So you basically want to automate that. You really want to make sure that coding standards, which is hard to see for me as a human being, because, well, I'm mostly stressed out because I have my other own things to do. It's very hard to see if I miss that single space or that single tab. But you will want to have the quality of that code in your production like that. So you want to check on it, and like I said, human being is not that okay, so you want to automate it. And that's basically what a build server can help you with. Because a build server is just some kind of mechanism, an application that will trigger a whole step of automation tasks and report on that, and then might kick off a new task or say, well, I'm done with it and you can do what you want. At Coolblue, we chose TeamCity to do this task of continuous integration. You have Jenkins, you have Hudson, you have Atlassian Bamboo, if I'm correct. For us, TeamCity was a better choice because we deploy both .NET applications and PHP or Node.js applications. And the thing about Jenkins around that time was that it wasn't out of the box that great in handling Windows applications. It's a bit better now. So yeah, we chose for TeamCity to go with that. And like you see, we have all kinds of projects configured in TeamCity, and each project consists out of a build chain, which basically is a sequence of builds which has a specific purpose. And that's our pipeline, how we work. From the moment that we start with creating a pull request to the moment we deploy, we'll run into these steps, which I will explain a bit more. And one other thing, those build scripts is basically, in our case, an XML file. We chose end as a build script tool, as a build tip tool, and build file, in our case, just looks like steps of targets which has a specific purpose. Prepare a build so we have directories for reports, or if we can clean some files, execute some linting tools or whatever. They're all described in XML files, and the XML files are part of the project. So the configuration of our continuous deployment pipeline is in the project itself next to the software, so you can easily maintain it and have a clear vision of what's going on there. So let's go to the first build step we have. Well, continuous inspection. This is basically what I was talking about checking of the code standards and the unit tests, because that's what we are doing here. And this is the moment that when a pull request gets created in GitHub, we automatically trigger this build step in our build pipeline. Which does a couple of things. It runs the automated tests. Can be unit testing, can be functional testing, and we run some static code analysis. Lint checkers like JS-Hint or JS-Lint will be run here, PHP Lint. Some other analyzers for code duplication to generate some metrics out of it. Don't repeat yourself tools. We have all kinds of mechanisms for what the specific language requires. For PHP, we have a different tool set than for Node.js and also for .NET. So let's say that my pull request went fine, and I validated that the coding standards were okay. Then a developer or my teammate is allowed to merge my pull request into the main line. Because what we validated is, well, my teammates did the logical check. The software, the automation stuff, did mainly the checks on coding standards, indentation, all kinds of stuff which we can automate away. and it makes sure that we had some regression testing, because the whole test suite will be run against my change and the entire code base after that. Which makes sure we have a pretty good feeling about what we have changed, that it is working okay, and that it fits into what we want as a company. So my teammate can merge the pull request, I have to change in the main line, and what do we have? We have continuous integration. First achievement. So that's nice, but now I still have a set of source files and assets which I have, and I need to get that in a package so I can get it deployed on a server, production server or accept server. Well, here are the kitties and the babies I was talking about. We got a lot of these kind of pictures. So yeah, we have two environments, the Linux and the Windows. For Linux, we went searching for a mechanism which was close to the operating system. And we ended up with RPMs as our method of packaging, because we have CentOS servers running, and it's something which is close to what the operations people and some developers at us are familiar with. They know how to run yum install or yum remove or whatever. That are mechanisms that they are familiar with. We put a package into the build step eventually on an RPM repository, and that RPM repository will make sure that it can update production servers or acceptance servers. When Puppet runs, it does a yum update of the package, and that will bring the new software on production server. Well, I already told a bit why we chose RPMs, because, well, we feel they are powerful. We have, well, in the RPM itself, control over file permissions and file writes, if you look at user access. If necessary, it has a clean uninstallation, and with yum downgrade, it also has some kind of easy, quick revert mechanism. You have tools like Capistrano and Webistrano, but they add complexity to your whole deployment process. It might be that they are fine for what you are searching for when you deploy software. For us, as Coolblue, we decided not to go for that kind of strategy, because it will add complexity where we didn't need it, and well, deploying high-quality software is difficult enough on itself, so let's keep simple where we can keep it simple. Then let's talk about Windows. For Windows, it's a bit hard to have something like a Windows update mechanism which you can mirror to have such kind of update system. So we chose to go for Octopus Deploy, which is able to deploy web services and desktop applications. And what it does, well, basically, instead of building RPM packages, that build process builds NuGet packages, which basically is also an archived package with some metadata on it. And it deploys it to the servers he needs to deploy it. And how does it look in a picture? Well, the source control mechanism builds the package to the build server, it sends it to Octopus, and Octopus, well, it's called tentacles to keep it in the analogy, use the tentacles to put packages on the servers he wants to deploy it. So we have packages, we have the RPMs or the NuGet, whatever, we have our software in a package, we're now able to distribute them. And in our case, the third step after that is to publish it to a test environment, which is nothing more than stating that the package is from the build server into the RPM repository server or into the Octopus deploy system so he can deploy it. Well, if we have that, then we have continuous delivery. We're now able automatically, whenever we merge the pull request, to get software onto the test environment without any manual interference. All the other steps are built automatically because that's how our build chain is set up. So that's nice. The other thing we do automatically after that is to publish it to an accept environment. There is no difference between that in our case. So testing an accept environment will automatically fall through and will be deployed to the latest version. But as a team, if I decide that my project shouldn't be on accept immediately, I'm able to change that configuration in the build pipeline. That's up to the team to decide. So you have some powers to alter that route if it's necessary. And the last step is to publish it to a production environment, so we can get it out there to have that killing conversion, or that awesome conversion factor which I created to really get it on our web service. So you might say that we now have continuous deployment. Well, not really, because we're missing some parts. Currently, I wouldn't dare to have this automatic chain going to continue to the production service, because if I deploy my change and nobody has tested it and I don't know when it gets to production and there's no active feedback when it is deployed, so it tests, yeah, I'm a bit scared about that. I do not want my change to go automatically on production, not because I don't want it to be on production, but I don't have the steps after that that alert me that something might be wrong, or that there might be some changes which causes me to revert it. So that's one of the differences between continuous delivery and deployment. Because if we look at continuous delivery, we basically talk about automated inspection, which is the first build step, and to deliver software into a certain server, except the production environment. That's something what's out of continuous delivery. What is continuous deployment then? Well, it's basically all the continuous delivery steps with the automated deployment to production, and also some automated post-deploy tests, so that you know that your deployment went successful, or that you have to revert or to change something in either way. So if you take a look at the whole workflow we have, well, we have the writing of the code, committing and pushing it, opening a pull request. The pull request gets reviewed, it is tested by continuous inspection, so it has unit tests run successfully, and we have the coding standards check. Then we build it, we package it, we can put it into staging, and we could put it into production, that's no problem. But the step that is missing is the automated post-deploy test. As we deploy, we do not have any automation running that checks if we are still up, does all the pages that we require to have an HTTP status of 200. Is that true, actually? Can we still log into the website? Can we add a product to our shopping basket? There's no automatic way for us right now to check that. So that's one of the reasons why we don't have continuous deployment. But let's say that we do want to have it. And that's something what we are working on currently and will be working on for a couple of months. If you think about post-deploy tests, what is it that you want to test? Well, I want to know for sure that my website is still up. So at least my homepage, is it functioning and gives it me a 200, and do I see some necessary data? One important thing for us is, well, can I put a product into my shopping basket, and can I put that shopping basket into an order? It's the most vital process of what we are doing on our web shop, so let's at least make sure that that is possible. So yeah, you want to automate some stuff. For example, it could be easily to add a new build step to run a script that tests at least, well, homepage still works, I get a 200, I get a certain amount of data in that, will be working fine. And that's something I can automate. What I also can do, I can check my monitoring. I can have my Nagios checks to see if something weird goes up. If my CPU, for example, increases after a deployment by a factor of 2 or 3, yeah, it might be that, I don't know, a commercial has run and a lot of traffic came popping onto the website, but the most logical thing to expect is that something is wrong in the deployment. So that might be a reason to fill the publisher to the production and to revert back and to say to the team, well, you have to investigate it further. So you can look at some monitoring. Other thing you can do, and you get bonus points if you know where the statistics are from, is to have your application measurements to check, well, if my number of logins filled more after deployment, let's say I had 0 filled logins before I deployed, and after that I got an increase to 30, 40, or 50, yeah, there might be something wrong in my deployment. So that could be another reason to say automatically kill the publishing and revert back to my old version, because that's where we feel safe with. And now filled logins is an example, but it can also be an increase in response time for certain pages by factor X. That's something that's up to you to decide when is a publish successful and when is it. But it are metrics that you can use to automate your success of a deploy. And another thing I was talking about, important test for our case would be if I add a product to the shopping basket, if that still works, that's something which you can put into a test package with Selenium, for example, or some other external application that does functional requests and check for success. That's also another thing that you can add to that. So I've showed some approaches how you can test for success, but how can we use that in our deployment to automate it? Well, one thing we can do, we can just say, well, let's deploy to the production server, and let's say that my metrics of the filled logins are increasing that rapidly. I just say automatically, well, no success, we revert back to the last version that was running. That might be the case, which is fine, but it also means that a lot of my visitors already have some problems with the website, so I'm not really enjoying the customer or increasing the customer satisfaction. Instead of that, we just dissatisfy them. So that's not something which we are very proud of and not the way to go for us. So we can figure out another way. Well, let's say that we make a copy of our production environment and create a pre-production environment, which is basically with the same setup, and we run or we deploy our new production code on that service, and then do load testing on it, figure out several test cases. Let's see how the metrics respond on that. If I'm not in a bad mode, then I put it into the real production. If I am, then we just block the publishing. Okay, might be a valid solution, but it will force me to have the entire production environment also set up in a pre-production environment just to determine if my code is safe enough to go to production, which is a bit costly, and it will take a lot of effort to mimic a high load on servers or to mimic certain activities that we cannot guess that customers will do. So that doesn't also feel really what we are looking for. But perhaps there's a sort of middle ground in these two solutions. And there is. That's what we call canary deployment. Basically, if you look at your production environment, and let's say we have 8 web servers, and we split them up in 4 parts. I just deploy to the first 2, and then see what the metrics of those 2 servers will do. If I'm happy about it, I also deploy it on 3 and 4, and so on and so on. If I see that the live customers on the first 2 servers result in 2 metrics that I don't like, okay, just revert those 2 servers, all the others are untouched, and then just a part of all the customers out there had, well, the not so satisfying production code. But it is an effective way to safely deploy and to revert for our case. So for us as Coolblue, this is something we're checking into if this really fits our needs and helps us in the way that we deploy. And then if we go back to our workflow and we can fill in that missing block of automated post-deploy test, after that, then we feel that we really have continuous deployment with no manual interference. Because to be sure on that, after the accept step, currently a developer has to push the run button to actually get it into production. That's a break in that right now. And eventually we need to get rid of that break, that when a pull request gets merged, that we put it into production automatically, and if something breaks, let's revert the whole bunch. About the canary deployment, there is one big challenge, because, well, with all deploy and revert steps, how do you cope with reverting data or reverting data structures that might have changed? Yeah, I wish I had the answer. I don't know yet. Hopefully, it's something that we are sorting out. But this is really something you need to keep an eye on when you're going to a canary deployment approach. How do you handle those cases? That's it for me. If you have any feedback or questions that I don't know, because we not have that much time, then please come see me. We have the blue shirts on, so we're easily to be found.
Oh, we still got 3 minutes.
Okay. 3 minutes less, sorry, Frank.
And for a 50-minute presentation.
Yeah. And we have beer for you. So
yeah, you'll be getting a drink.
Around there we'll get them.
Are there any questions? You're just thinking beer now, but are there any questions now to Paul? Yeah, there. I'll go to the farmer's corner there. Oh. Have to run.
Yeah, meanwhile, one thing to mention, we're starting up our dev blog in which we write about our experience. So check out the dev blog, it can really help, or at least we describe our journeys into microservices and all kind of other stuff. So check it out.
Yeah. Hello. First of all, thank you for presentation. And the question is like about pull request and on which moment on your scheme you merge this new branch and what you actually test. You test this exact branch first, or you first merge it to master or your main branch and then test everything, and how does it work? Thank you.
What we test is if I'm correctly, the exact change as you have made it in your fork. So basically the build server will check out your entire fork and run all the tests against that one. So you can have the inspection and the unit test of what you have changed, and not that your colleague next to you might screw something up and that will interfere with your build. Because your integration might be perfect and his might be not, but we don't want both parties to end up with a situation that you cannot put something into production because he still screwed up something, goes on holiday for 2 weeks or whatever. So those are separate processes. Before you can merge in GitHub, the continuous inspection step, so checking unit tests and the coding standards, that will be run. If those fail, then no, unfortunately GitHub allows you still to merge them, but you'll see a big red cross that please don't do it. Answer that your question a bit? Then let's meet for a beer. That's the best solution.
I'll take another question on this side.
Another topic or problem which you didn't mention was how do you handle test data? Because often the production data sets are very large, and you also have privacy issues because customer data is in the production, customer details are in the production data, but you still need to get reasonable production data to be able to run all those tests that you mentioned. How do you solve that problem?
Yeah, you mean that if you have a pre-deploy environment to test your production on, or for the unit test?
Well, you mentioned running unit tests before you merge code, but or testing the code, but often that also requires input data. Yeah. And that requires input data, which is, I mean, I've seen the shopping cart on production failing because there was data on production that caused it to fail. And that's always a big challenge of getting reasonable data to the test environments without putting in the customer details and whatever. Do you have smart ways to handle that?
Well, then I have to be honest, no, because let me explain.
Very honest.
No, we have a lot of heritage code. I don't want to say legacy, we call it heritage, sounds a bit more nice. And we're currently, for the last year, working into getting unit tests going, which is hard enough on its own. And basically the thing you are talking about is more integration tests when you're running to a whole load data set. Because for unit tests, we can mock all kind of stuff. And integration test is something, well, new products will work with that mechanism, but the whole big web shop project currently isn't, which is a shame. We were working on that, but yeah, that has to come up. So that, if I have ideas, then hopefully I'll know to find you. Cool. Well, thank you all much for joining. Contact details. And,
I know there's a lot of questions, but we are on a time schedule. He's paying for the drink, so he'll be here.
yeah.
He's got a quite visible shirt on. You can't miss him.
Nope.
So thank you very much, Paul, for your presentation. And yeah,
thank you.
Still another drink.
Yes, thank you.